Hi class, in this lecture here what we want to do is we want to talk about what are called the product to sum and sum to product formulas for trigonometry. And so all I want to do in this lecture is, I'm just going to introduce the formulas and then I'm just going to work quick examples of each of the, first I'll do the product to sum and then I'll do sum to products, and then at the end here I'm going to verify for you one trigonometric identity using these formulas. Okay. So what we're going to work through, again, just going to talk about how you use the product to sum formulas, and then we're going to talk about how you use the sum to product formulas. All right, so here are the product to sum formulas. So basically it's like when you have sine of alpha times sine of beta, or cosine of alpha times cosine of beta, or sine of alpha times cosine of beta, or cosine of alpha times sine of beta, okay? And the formulas are just as follows, okay? And I'm not going to read through all of them. I'll read through the first one here. So if you have sine of alpha times sine of beta, that's going to be equal to 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. Okay, so it's literally just taking a product and breaking it up, in this case, as a difference. Or like here, if you have cosine of alpha times cosine of beta, that's 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. And down here you can see the other two formulas here. Okay, so what you want to do, hopefully you have, think about these are just formulas to put in your toolbox for working with trigonometry. So, put these or write them down on some cheat sheet that you may or may not have for trigonometric formulas and trigonometric identities, and just keep it tucked away. All right, so let's do the following here. So let's express this product here. So I'm multiplying two trigonometric functions as a sum or a difference. All right, and so here I have sine of 5x times sine of 2x. Well, that looks a lot like this right here. Okay, so this is my alpha and this is my beta. Okay, so this is equal to, so you just got to follow the formula. It's 1/2 and then in parentheses cosine of alpha minus beta, so 5x minus 2x, minus cosine of alpha plus beta, so minus cosine of 5x plus 2x. And then you just have to clean this up. So this is 1/2 of cosine of 5x minus 2x. What does that get us? That gets us 3x. Minus cosine of 5x plus 2x is 7x. So you're going to leave this as factored with the 1/2 out front. But all you did was here, you took a product and you wrote it as a difference here. That's it. So now look at this one. Let's take cosine of 7x times cosine of x, and I want to write this as a sum or difference. Well, look, that looks like cosine of alpha times cosine of beta. So 7x here is my alpha, and x here is just my beta. So this is equal to, all right, cosine, cosine. So it's 1/2 cosine alpha minus beta. So 1/2 cosine of 7x minus x plus cosine of alpha plus beta plus cosine of 7x plus x. Now look, you just have to clean this up. So this is 1/2 of cosine, and this 7x minus x gets me 6x, 7x plus x plus cosine of 8x. And that's it. I've got it. So all I did here in this case was I took this product and I wrote it as a sum. Okay, now you can go backwards. All right, so you can go from sums or differences to products. Okay, so we just call these the sum to products formulas. So sine of alpha plus sine of beta, that's equal to 2 times sine, and this is important here. This is sine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. And you can see it's the same for pretty much all of them. Sine of alpha minus sine of beta is 2 sine of alpha minus beta divided by 2 times cosine of alpha plus beta divided by 2. And then you can just see the other two formulas here. Okay, you have cosine of alpha plus cosine of beta and cosine of alpha minus cosine of beta. And all we want to do here is just talk about how we can use these formulas and simplify it. And just a quick note here: these two formulas at first glance look exactly the same, but don't notice this negative here. So just be mindful of that when you use that formula. All right. So look, let's take this one. So let's express these two sums as a product. So I have sine of 7x plus sine of 3x. So that looks like this right here, this first one. So 7x is my alpha, and 3x is my beta. All right, so what is the formula here? It's 2 sine of alpha plus beta divided by 2. So this is 2 sine of 7x plus 3x divided by 2. And then it's cosine of alpha minus beta divided by 2. Cosine of 7x minus 3x divided by 2. Well, look, this is 2 times sine of 10x divided by 2 times cosine of 4x divided by 2. Well, look, just clean up the inside of the trigonometric function. So this is 2 sine of 5x cosine of 2x. All right. And we got it. We started as a sum and we wrote it as a product now. All right, so now this is cosine of 3x, so that's my alpha, plus cosine of 2x, that's my beta. So look, you're going to use this formula here, cosine of alpha plus cosine of beta. Okay, so this is 2 cosine of alpha plus beta divided by 2. So this is 2 cosine of 3x plus 2x divided by 2. Times cosine of alpha minus beta divided by 2. So cosine of 3x minus 2x divided by 2. Well, look, here you're just going to get cosine of 5x divided by 2. We're going to leave it as that. We're not going to write it as 2.5, okay? And then this just becomes 3x minus 2x. This just becomes cosine of x over 2. And we got it. Got it. So this is just, just straight following the formula here. Just following the formula. All right, now let's use these formulas to verify trigonometric identity here. All right. Suppose you have something like this. I want to verify this. Sine of x plus sine of 3x divided by cosine of x plus cosine of 3x. And I'm saying, hey, you know what this is equal to? This is equal to tangent of 2x. So you're going to have to pick a side. So you're going to pick the left-hand side here. All right? And look, you have sums. And you know what you might want to do? You might want to take these and write it as a product. So start on left-hand side. And you're going to use the sum to products formula. All right. So this is sine of alpha plus sine of beta. So what does that become? So looking back, sine of alpha plus beta, this becomes 2 sine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. All right, so the numerator here is just going to become 2 times sine of x plus 3x divided by 2 times cosine of x minus 3x divided by 2. Divided by, now cosine of x plus cosine of 3x, boom, right here. It's 2 cosine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. So this is 2 times cosine of x plus 3x over 2 times cosine of x minus 3x over 2. And I'm hoping that this is going to simplify to tangent of 2x. All right, well, look what cancels out. The 2's cancel out right off the bat. Boom, boom, those are gone. X plus 3x is 4x divided by 2, so this becomes sine of 2x. And this is cosine of minus 2x. Look, cosine is an even function, so this is the same thing as cosine of 2x, but I'll just leave that there for now. Divided by here, you get cosine 4x divided by 2 cosine of 2x, and then cosine of, oh, look here, cosine of minus 2x. Well, look, what cancels out? Cosine of minus 2x, cosine of minus 2x. And then you're left with sine of 2x all over cosine of 2x. Ha! This is awesome. What is sine over cosine? Just tangent. So we got it. So look, you know, as always, just try your formula, right? When you see, you know, oh, I see a sum. Let me write that as a product. And you can see, you know, just using the identity going right in, you know, it simplifies and you'll be able to verify the identity. All right, class, I know this was a rather quick lecture, but this is just an introduction to the formula. You know, so as I said here, you know, previously, you know, put these formulas on a cheat sheet. Just have them handy, you know. And then, you know, when you see, you know, you got a sum, hey, I want to write it as a product, go back and look at your formula and use it as applicable. All right, class, as always, I am here to help if you need anything.